Question number 30. It says two identical small balls, each of mass small m, are held on the top of a triangular wedge of capital M mass and height capital H. This is small h, which is shown over in the figure as well. That it is resting on a frictionless horizontal floor. So this floor is frictionless. When the balls are released, they roll down in inclined faces of the wedge and at the bottom get stuck in the special traps. So there are special traps. These balls are going to slide down and will trap there. How far will the wedge shift during movement of the ball related to the wedge? So these balls are being released, they will come downside, and till these balls are moving, this wedge will be shifting. So what is that displacement that we need to find out? And this horizontal floor is frictionless. So we can consider this two balls and this wedge as our system. So considering this entire setup as our system, and we will find that in this entire system there will be no external force acting in the x direction, and initially the system was at rest. That will imply x coordinate of center of mass will not change. So initial location of the center of mass x coordinate and final location of the center of mass x coordinate will remain the same. Consider this figure. So let's consider this ball as 1, this ball as 2. This will going to come here, this is going to come there. Now ball 1 will be displacing in the x direction by this amount, which is h cot beta. This is beta, this is h, so this is going to be base, which is h cot beta. So h cot beta towards positive x direction will be the displacement of ball 1 with respect to wedge. Similarly, the second ball is going to trap over here, so it has to travel in the negative x direction by h cot alpha. This is alpha, right? So these are the displacements that are going to happen to these balls with respect to wedge. Now we are going to calculate the center of mass with respect to ground. So we write the center of, we can claim that the change in the position of center of mass must be 0. And we know the change in position of the center of mass will be equal to the m1 delta x1 plus m2 delta x2 plus m3 delta x3 divided by m1 plus m2 plus m3. m1 is m, m2 is m, m3 is capital M, so I have written there letters. This has to be 0. This could be simplified as you can take this small m outside. So delta x1 is a vector plus delta x2 is a vector plus capital M delta x3 equal to 0. Now this delta x1 is trying to tell the displacement of first particle with respect to ground. Delta x2 is the displacement of x coordinate of the second particle with respect to ground, and delta x3 is of the wedge with respect to ground. Of course, only on the x coordinates. Now we are considering that the wedge is shifting, let's say by x naught amount in the positive x direction. So if wedge goes towards positive x direction by x naught value, that means delta x3 vector is going to be x naught I cap. Now to find out the displacement of one particle with respect to ground, we will write in the displacement of the first particle with respect to wedge plus the displacement of the wedge itself. So delta x1 is going to be basically x naught I cap, which is of the wedge displacement, plus the displacement of the one particle with respect to wedge, which is h cot beta. So that's going to be h cot beta. So this is going to be total displacement of particle 1 with respect to ground. Similarly, the displacement x displacement of the particle 2 with respect to ground will be counted in the same fashion. That means displacement of the 2 with respect to this wedge and plus the displacement of the wedge. So displacement of wedge is x naught I cap, and this is in opposite direction, so it's minus h cot alpha I cap. Now we got all these vectors or this x coordinate displacements. Now we can put over here. So it's like a small m. Delta x1 is x naught plus h cot beta. Delta x2 is x naught minus h cot beta, and this plus capital M. This is x naught. There was I cap common. We can cancel it out. So from here we can collect x naught together, which is going to be m plus m, that is twice m small, and this is capital M, and this h cot alpha will become positive this side and h cot beta will become negative, and there will be m coming, so mh cot alpha minus cot beta. From here x naught is coming as small m h within bracket cot alpha minus cot beta divided by capital M plus twice m. Now all numbers are known to us, like small m, capital M, alpha, beta. They are given to us in this figure in question. So this is going to be the displacement of the wedge with respect to ground in the positive x direction. So we will write this is going to be in the I cap direction. So that's our final answer. Thank you.